Ay, 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 we are almost done. Oh boy. Boom. All right. So, another instance of how the plan cache can lie to you. And again, this is not limited to parameter sensitivity. I just find it's easy to get the point across with parameter sensitivity. You can have bad guesses, bad estimates for a bajillion reasons. It's just really easy to get this behavior to show with some parameter sensitivity. So let's run this and let's open up the query plan. And before we go looking at anything, I'm going to run the different copy of it, and I'm just going to let that finish while we talk about this over here. So in this version of the query plan, this is the actual factual query plan. We have an index seek, which is estimated to cost 96% of what the plan needs to do, right? Is that 96% of the effort is going to be in this index seek. We get one row out of an estimated 4,140, and then this sort is estimated to cost 4%. All right, so these two things make up the entirety of the plan cost. These two things don't have zero cost to them, and you can, I mean, whatever. Not really, not really a big deal. Why? But what's interesting is this index seek. Now, this index seek does something that I consider kind of goofy. So the seek predicates, because of the way this index is set up, where creation date is first, these seek predicates seek to a very, very wide range that's not really formatted in the most readable way, but the beginning of the range is January 1st of 2007, and the end of the range is December 31st of 2018. So we did technically seek, technically, but we seeked the entire size of the table. If we look at how many rows we had to read to get to seek, it's the entire thing. We the whole thing, right? And the reason why that happens is because score is a residual predicate over here. So though we are able to seek the entirety of the index with these two values, evaluating this predicate that filters out more rows has to be evaluated over this entire range. And so for a score of 25,000, you can rule out an awful lot of rows. For a score of 1, you cannot rule out that many rows. Slight difference there. And that's why this query takes about 4 seconds. All right, 4 seconds there. And the majority of that time is spent in this operator. So the index seek is still estimated to be the costliest part at 96%. Right? Oops, I didn't mean that one. At 96%, and that takes this still takes under a second, right? So fairly quick. Maybe not like hedge fund quick, but fairly quick. Then the issue becomes that this sort, which costs 4%, is what makes up the majority of the execution time. If you subtract 824 milliseconds from over here, because remember, row mode execution plans, the costs are cumulative, going from right to left. This sort runs for about 3 seconds, and the rest of the plan finishes up rather quickly. Only adding about 200 milliseconds over the duration of it. So the issue here is that the operator costs are all amok. Yes, they are. They were perhaps correct for the initial iteration of the plan, but they were incorrect for the second iteration. And if we look at the query plan, right, we look at what's going on here, we'll see that that initial estimate carries over here. So we get the plan that was accurate for that first execution, and if I see this, I'm going to be like, look at it and say, well, golly and gosh, how are we going to make an index seek any better? And granted, there are ways to do that, but that's not what this is all about. There are ways. There are ways. Oh, there are ways. But we'll talk about that in a different video. So the issue here, of course, is that, you get that cached plan based on the first set of parameters that get passed in. And just like in other parameter sensitive issues, other parameter sensitive examples, we're only going to see the call for the initial compile plan. If the initial compile plan isn't the problem, then we have to do a lot more investigating to figure out which parameter is the problem and what value that parameter has to be for the problem to present itself. And just like in other parameter sensitivity issues, we also have to know that we have to execute this first and then this in order to get that behavior. So again, that can be rather tough and time consuming. And this is, not to diverge too much from the intent of the video, but this is one of those reasons that a monitoring tool can be invaluable, is because you have a better chance at collecting multiple versions of the same plan, perhaps with different parameters as well. So good times there. If you would like a monitoring tool recommendation, just shoot me an email. I'll give you one. I don't make one, don't worry. I'm not ready to start that just yet. All right, cool. So we've seen in this video that operator costs in cached plans can be misleading. They can lead you to start examining one operator when another operator was really at fault, and this is a sort of a simple example where maybe you could do some more troubleshooting to really get to the bottom of things here. But I don't know. Sometimes people might just look at the execution plan, see that index seek, and think, Lord, we can't get any more perfect than that. We did an index seek. What else what can we possibly tune here? What could possibly be better than an index seek? God. Whew. We're professionals. Anyway, that's it for this one. In the next video, I'm all excited now, we're going to talk about how batch costs can be a little weird. So I will see you over in that video then. Thank you for watching.